So, hello students, welcome you all. Welcome to this YouTube channel. You're most welcome. So, this is a question which is being asked in your Engineering Services 2020 examination. Let us solve this question. So, first let me read the question statement. A transformer with a 10 raised to 1 ratio and rated at 50 kVA 2400 oblique 240 volt 50 hertz is used to step down the voltage of distribution system. The low tension voltage is to be kept constant at 240 volt. If the transformer is fully loaded at zero point 0.8 power factor lag, transformer is fully loaded at 0.8 power factor lagging, then calculate the load impedance connected to the low tension side. So these four are the option A, B, C, D. We have to solve this question and find out the correct option. After solving this numerical, we have to choose the correct option out of A, B, C and D, right? Only one option is correct, that we have to find out after solving this numerical. So have you understood the question? Let me reiterate the question once again. A transformer with a 10 raised to 1 ratio and rated at 50 kVA 2400 oblique 240 volt 50 hertz is used to step down the voltage of distribution system. The low tension voltage is to be kept constant at 240 volt. If the transformer is fully loaded at 0.8 power factor lagging, then we have to calculate the load impedance which is connected to the low tension side. Out of ABCD, only one option is correct, that we have to choose the correct option after solving this numerical. So how to solve this numerical? That's very easy bit, right? So load impedance is given by Z suffix L, ZL, and since he is asking the load impedance which is connected to the low tension side, and low tension side is 240 volt, right? He is saying that low tension voltage is to be kept constant at 240. He is saying that, right? So which is secondary side? So it will be V2 divided by I2, right? That is the load impedance. Okay, so now you know this V2. He is saying that low tension side voltage is to be kept constant at 240. He is saying that it is given that low tension side voltage is kept constant at 240 volt. So 240 volt is low tension side voltage. Alright, it is given in the question, and now your job is to find out this current I2. Once you find out this I2, you will be able to find out the load impedance, right? So our job is to find out this load current I2. Okay, so now to find out this load current I2, it is given that the rated output of the transformer is 50 kV. That is a rated output, right? It is a rated output and not the input, right? So this is the nameplate rating, and you know that nameplate ratings are rated output ratings and not the input rating, right? So nameplate rating is output rating. So this is the rated output. So 50 kVA is the rated output, or you can say full load output. So now you know that rated output, that is 50 kV, right? So load in kVA, load in kVA is basically 50, right? 50 kVA. All right. So load in kilowatt, load in kilowatt, you can calculate load in kilowatt. Kilowatt is equal to kV cos phi. All right. Kilowatt is equal to kV cos phi. So kV cos phi. Cos phi is the power factor. Power factor is 0.8. It is given in the numerical. 0.8 lagging. All right. So here you write this is 50 into 0.8. 50 into 0.8. So it comes out to be equal to 40 kilowatts. All right. It comes out to be equal to 40 kilowatts. All right. Okay. Now this data will give you the current I2, right? So this 40 kilowatt is nothing but 40 kilowatt is nothing but 40 kilowatt is nothing but V2I2 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 cos phi V2I2 V2I2 cos phi, right? Okay. Now from here you can calculate I2. 40 kilowatt means 40 into 10 to the power 3 watts. V2 you know it is given that 240 volts. I2 you have to calculate, and cos phi is basically 0.8. It is given, right? So now very easily you can find out this current, load current I2. It is 40 into 10 to the power 3 divided by 240 into 240 into 0.8, right? So you solve this. When you solve this, you can find out this is equal to I2 is equal to 208.33 amperes. So now what is the load impedance from equation 1? So from equation 1 very easily you can find out the load impedance. From equation 1 very easily you can find out the load impedance, because now you know the load current I2. So 240 that is V2, and load current that is 208.33. I2 is 208.33. So 208.33 is basically, when you solve this, it will give you 1.15 ohms. All right. So tell me which option is correct. Option C is correct. That means option C is correct option. So C is the correct option, right? C is the correct option. Option C is correct. So thank you very much. Thanks for watching. If you like all such kind of numerical, do subscribe to this channel for regular updates for GATE and ESC questions. Thank you very much. Thanks for watching.